Once the experiment is done, we have to go for the volumetric analysis. The aim of the Marshall mix design is to determine the optimum binder content using these tests. First, the test will be done at some trial and various percentage of bitumen content, and we have to find out what would be the binder content which will gives you the maximum stability value and the flow value, and some other requirement has to be fulfilled, okay, to determine the optimum binder content value. So now that how to determine the optimum binder content will be studied using the volumetric analysis. So volumetric composition of the compacted mix can be studied using the picture here. Now you can see here the total, let the total weight of the bituminous mix, let us take it as W, and the volume of bitumen mix will be V. So weight of the bitumen mix can be found out after the completion. Once you extract the bitumen sample, you have to measure what is the weight. That will gives you the weight of the bituminous mix. And volume, you cannot directly calculate the volume of the bitumen. So what we will do is, to have an accurate estimation of the volume of bitumen, we will take the weight of the bitumen in water, and also weight of the bitumen will be taken in the air. Okay, the difference in weight can be found out to determine the volume of bitumen content. Okay, so let us see how the volumetric analysis will be done. Let the weight of the compacted specimen will be the Wg gram, and the volume of the compacted specimen will be V, and this V is nothing but the total bulk volume of the compacted specimen. Here, when I talk about the bulk volume, this consists of both volume of aggregates plus volume of bitumen and also the voids that exist in the bituminous mix. All these constitutes the total volume or bulk volume of the compacted specimen. The next is, see here, you can see this is the volume components. The picture here will show the volume component. The total volume of the bituminous mix consisting of part of the volume that is filled with the mineral aggregate. So we have in the first part, we have only the aggregates volume, that Vm represents the volume of aggregates alone, and we also have the volume of bitumen and the voids that exist in the bitumen. So now the total bitumen what we are having here, this is the total bitumen content. In the bitumen what we have two types of bituminous volume. One is the volume of bitumen available in the voids, okay, that is which has been filled or coated around the aggregates. That is nothing but the volume of bitumen filled in the voids of the aggregates. There is another component of bitumen, that is the adsorbed bitumen. So now it is say that if you have any aggregates porosity, some proportion of aggregate bitumen will be absorbed, that will be filled inside the voids of the aggregate, and the remaining will be coated here. Okay, so this portion of bitumen which has been absorbed by the voids in the aggregates, that we call it as the AVAB or absorbed bitumen. Since that will be inside, that will be absorbed bitumen will be considered inside the total volume of the mineral aggregates, and so that VB is the volume of bitumen that is available in the voids, which is there. You can see here within these voids we will have the bitumen content. So this will be the VB, the voids available in the mineral aggregates void. So that's we have to determine. Let us consider the volume of mineral aggregates. So this the volume where we have just aggregates, that is represented by Vm. Thus the total voids, air voids in the mix will be equal to total volume minus voids in the mineral aggregates. Then let us consider the volume of bituminous mix as Vb and absorbed bitumen as Vb. The rest of the binder, what is there in the mineral aggregates, Vb will be equal to the absorbed bitumen plus the bitumen that is available in the voids. Okay, that will both together constitutes the, as I mentioned here, the absorbed bitumen and the bitumen that is there in the voids of the mineral aggregates. The both constitutes the total amount of bitumen. So using that we can find out the what is the volume of air voids. Volume of air voids VV will be equal to total volume minus the volume of aggregates plus the volume of BF. That is nothing but the bitumen filled in the voids of the mineral aggregates. So you have to observe that we are excluding the absorbed bitumen is excluded. So why we excluded that? Because the absorbed bitumen will be within this. Okay, the VM will be both volume of aggregates plus volume of adsorbed bitumen. That's why we are excluding. So to determine the total voids, VV should be equal to V minus VM plus VFB. So thus the void filled with the bitumen alone will be equal to VMA, voids in mineral aggregates, minus VM is nothing but VM, voids in mineral aggregates, minus VV will gives you the total voids filled with bitumen only. So the voidless volume of the paving mix will be equal to V minus VV. After determining the stability and flow value, we must conduct these volumetric analysis. And next is we have to find out the theoretical specific gravity. So we know that the bitumen sample consists of various material with different specific gravity value. Let us say we have the G1 corresponds to coarse aggregates, G2 corresponds to specific gravity of fine aggregate, G3 corresponds to the filler material, and GB corresponds to bitumen. So now the theoretical specific gravity can be calculated using the what is the weight of the fine aggregates that you have used and specific gravity of the fine aggregate, and weight of the coarse aggregate that we have used divided by the specific gravity of the aggregate. So using this expression you have to determine the theoretical specific gravity. So after determining theoretical specific gravity, find out what is the bulk specific gravity. Okay, so bulk specific gravity or actual specific gravity. To determine that, you take the weight of the compacted specimen in water and again in the air. Okay, so the ratio of WM divided by WM minus WM. So where WM is the weight of the mix in air and WW is the weight of the mix in water. By determining that, we will get the what is the actual specific gravity. So then go on to the voidless analysis. Determine what is volume of voids, volume of bitumen, volume of mineral aggregates, and voids filled with aggregates using these expression. Once the volumetric analysis is done, you have next step is to determine the optimum binder content. So optimum binder content will be determined based on the average value of above properties that are determined for each bituminous mix with the different bituminous content. Let us say you have prepared some 4 mixes with the first one using the 2% bitumen, second trial is using 3% bitumen, third using 4.4% and the next is 5%. So now for each and every proportion of bitumens that we have conducted, you have to determine the stability value and the flow value and find out the volumetric analysis. Once the volumetric analysis is done, then you have to plot the various graphs in which the graphs includes the binder content versus the corresponding Marshall stability value. The second graph, the binder content versus Marshall flow, binder content versus percentage A voids, binder content versus void filled with bitumen, and the binder content versus the bulk specific graph. So if you look the graph, so these are all the graph that you have to plot after the completion of stability test and the void analysis. So now as the first graph is the binder content versus the density. So this chart indicates that as the percentage of bitumen content increases, the density will increases up to some optimum point, and then the density value reduces. This is because that the total, as the bitumen percentage increases, the total volume of aggregates will be replaced by the bitumen. So this is because of this reason, the density will, as the volume of aggregates is reduced, the density value also reduces. So now using this graph, you have to find out what is the binder content at the maximum density value. So here you will have one binder content. The next is you have to find out the percentage bitumen versus the stability value. Similar to density, the stability value will also increases as the bitumen content increases up to certain point. Beyond that, the total voids of aggregates will be replaced with the bitumen. The stability value will also reduce. So in this graph also find out what is the bitumen content at the maximum stability value. Then the next third graph is you have to plot optimum bitumen content versus the flow value, that deformation value you will have. Okay, so as the flow value will increases as the bitumen content increases. Okay, so here which bitumen content has to be taken, I'll discuss that. And the fourth graph, we need to plot bitumen content versus voids in the bituminous mixes. Similarly, percentage of bitumen with the voids filled with the bitumen. Okay, so what are all the bitumen content we have to determine? The first is we need to consider what is the binder content corresponding to the maximum value. So where you will get the maximum stability, at the same point, almost at the same point, your density will also be more. Okay, so what we have to do, first find out what is the bitumen content corresponding to the maximum stability, find out what is the bitumen content corresponding to the maximum density, and also find out the bitumen content corresponding to 4% air void. So this is because that I've already stated the aim of the mix design, one of the aim of the mix design is to have sufficient air void such that when the bituminous mix is subjected to the traffic, if a cushion will be given for any additional compaction that can happen because of the traffic. That's why the bitumen mix what we prepare, that must consisting of 4% of air void. So now here you take this graph. In this graph, for the 4% air voids, find out what will be the bituminous content. We have 3 bituminous content, B1, B2, B3. Take average of all 3 value, that will gives you the optimum binder content for that particular mix. After the mix design is done, we have to check whether the prepared obtained bituminous mix will fulfill the requirement as per the specification. So we have to check the results what we have obtained using the Marshall mix design specification. When any mix design is done, you should have the maximum stability value of 340 kg and flow value should be 8 to 17, it is in terms of 25 mm units, and the mix what we prepared, that should have minimum void content between 3 to 5% and void filled with bitumen or VFV what we have estimated, that should be in between 75 to 85%. Mixes with very high stability value and flow values are not desirable, as the pavement constructed with such mixes are likely to develop the cracks due to heavy moving loads. In the next class, we'll take one example and we'll solve the numerical on how to determine the optimum binder content using Marshall stability mix design. Thank you.